Hello Algebra 1 students, and this is Mr. Wilson, and in this video we are going to learn two different ways to solve quadratic equations. Now I need you to take notes on paper. It does not need to be grid paper like this. Now the two ways that we're going to learn how to solve quadratic equations is by graphing, and then we will also learn how to solve quadratic equations by square rooting. We're going to look at both of those in this video. Alright, so let's just dive right into our first example. Let's say that I wanted you to solve the equation, say 0 equals x squared minus 25. Okay, so first of all, let's solve this equation by square rooting. Okay, so I'm going to write the equation again down here. 0 equals x squared minus 25. Now, in order to solve this equation by square rooting, first of all, we are going to have to solve for x squared. Now remember, solve in this case means isolate. So get everything to the other side of the equation. So in order to get the x squared isolated, we have to add 25 to both sides. So this means that 25 equals x squared. Now let's think about what this equation is saying. This equation is saying, what number, when you square it, will equal 25? Now you should realize that the first number that comes to your mind is that x could be 5, right? Because, of course, if you take 5 and then you square it, you get 25. But there's another number that when you square it, you also get 25. What about inside of parentheses? Negative 5. If you take negative 5 and you square it, look at that. You also get positive 25. So that means that when we are solving quadratic equations, you will sometimes get two possible answers. Okay? So there are two possible solutions to this particular quadratic equation. Now, what we really did here was we took the square root of both sides of the equation here. Okay? Anytime you're solving an equation, what you're really doing is you're doing the opposite. Okay, so like right here, when we solved for x squared, you did the opposite of subtracting 25, which is add 25. That's how you solved for x squared. Down here, in order to solve for x, you took the square root of both sides, because square rooting is the opposite of squaring. Okay? But the key here is that whenever you square root both sides of the equation, you also have to include this thing on the front end, plus or minus. You see that symbol there? It's a plus sign on top of a minus sign. The way we pronounce it is plus or minus. So the way that you could say this is that x equals plus or minus, and then the square root of 25 is positive 5. Okay? So x equals plus or minus 5. And the way that that can be written in two different ways is x is positive 5 or x is negative 5. Okay? So that leads into both of these possible solutions. Now let's just look at another example, just using square rooting this time. Example 2. Let's say I wanted you to solve this equation. Solve 2x squared minus 32 equals 0. So again, the first step here is to solve for x squared. Solve for x squared. So in order to do that, the first step is to add 32 to both sides of the equation. So 2 times x squared equals 32. Now the next step to solving for x squared is to divide both sides by 2. So x squared equals 32 divided by 2 is positive 16. Now the last step to solve for x is to do the opposite of squaring, which is square rooting. So square root both sides, but over here you have to include plus or minus. Okay? So x equals plus or minus square root of 16 is 4. Now this, of course, just like it did up here, means that x equals positive 4 or x equals negative 4. Okay? This is exactly what that means. Okay? So we have, again, two possible solutions to this quadratic equation, positive 4 and negative 4. Both of these will make that equation true. Now let's look at the second way to solve quadratic equations. The first way we learned was by square rooting. Now we're going to learn by graphing. So the first step to solving a quadratic equation by graphing is to graph this, but with a y here. So we're going to graph y equals x squared minus 25. Okay? So let's do that in our calculators. Okay, so we're creating a graph. Y equals x squared minus 25. Okay? So once we've graphed this, we want to know if we stick in a value of 0 for y, what is x? So if y equals 0, what is x? Let me bring back the paper that I wrote on during the last video. Look over here. In our table of values, look at where y is 0. For example, y is 0 right here. When y was 0 in this particular function, x was negative 3. And we had a special name for that point. When y is 0, the x value is called the x-intercept. Right? The x-intercept is right here. This is where y is 0. But y is 0 at another place in this particular function. Y is also 0 down here. And in that case, x is 1. And that corresponds to that x-intercept there. So there are two possible places where y is 0. And so we say that the x-intercepts are negative 3 and positive 1. So this question that we asked here, if y is 0, what is x, is the same exact thing as asking find the x-intercepts. And another way of phrasing that question is find the, what we call, zeros of the function. We are finding the zeros. That just means find where y is 0. So let's use our calculator to do that. I'm going to go to Menu, Analyze Graph, 0. So this will allow me to find the zeros of this function. What I'm going to have to do first is set the lower bound. So I'm going to scroll over here. Right here, you can see that the graph intersects the x-axis right through here. So we're going to set the lower bound so that it's to the left of that point. Upper bound, we're going to scroll over, we're going to set it to the right of that point. Now notice that it highlights the intersection point. It highlights the 0. And right here is the ordered pair. I'm just going to click on that, wiggle my finger, come on, click on that, wiggle, drag it up here a little bit. Okay? That right there is the ordered pair of that intersection point. Notice that y is 0, and what is the x value? -5. So -5 is one of the x-intercepts. X equals -5. But notice that we have another intersection point over here. Let's find that intersection point. We're going to go to Menu again, Analyze Graph, 0. We're going to set the lower bound so that it's to the left of this new intersection point. The upper bound is going to be to the right of that intersection point. And look at what the ordered pair of that new intersection point is. 5, 0. Again, y is 0, but now x is +5. Okay? So, in order to solve a quadratic equation by graphing, you need to graph this function in your calculator, find the zeros of the function, and those zeros correspond to the x-intercepts, which are the solutions to this equation. 0 equals x squared minus 25. Okay? Now notice, of course, that the two different methods give us the same exact answers. X is +5 or x is -5. Alright, let's look at a couple more examples. I'm going to solve these equations by square rooting, just because I think that's what you probably need more practice with, even though solving by graphing is very easy to do, and it will always work for you. But I want to do a couple more solving equations by square rooting. So let's look at example 3. How about this one? 5q squared minus 20 equals 0. Let's solve that by square rooting. So the first thing we're going to do, solve for q squared. So first thing, add 20 to both sides. So 5q squared equals +20. Second step is divide both sides by 5. So q squared equals 4. Square root both sides. We need a plus or minus out here. So q equals plus or minus square root of 4 is 2. So the solutions are +2 or -2. Okay? That was a pretty easy one. Now let's look at another one. How about this one? Example 4. How about x squared plus 36 equals 0? So we're going to solve that. Okay, so the first step is to subtract 36 from both sides. So x squared equals -36. And then the final step is, let's try to square root both sides, plus or minus out front. Now you might be tempted to say that x equals maybe plus or minus 6, right? Because the square root of 36 is 6. But we're trying to take the square root of a negative number. Is that possible? Let's see. Let's see what our calculator says if we try to take the square root of a -36. So the square root button is right here. We're going to hit Control and then the square button to get the square root. -36. Enter. Ooh, look at this. We get an error message. non-real calculation. So what we've just found here, remember at the very beginning of the school year, we talked about these things called real numbers? It turns out that the square root of negative 36 is not a real number. Not a real number. Isn't that kind of weird? If it's not real, what is it? What does that mean if it's not a real number? Well, what it means is that basically there is no solution. There is no real solution to that equation. There is no real number that will make that equation true when it's plugged in for x. Let's maybe if you're doing a problem like this, you think something's a little bit wonky and you want a second opinion. Well, we know how to find a second opinion. Try to solve the equation by graphing. Okay? So let's try to graph this guy. So we're going to graph the function x squared plus 36 equals y. Let's try that. Let's get a second opinion. So y equals x squared plus 36. Enter. Okay. So first of all, we don't see the graph at all. That's not a big deal. Let's try to zoom out. See if we can see the graph. If we zoom out a couple times. There it is. Okay? So the graph is up there. The fact that we couldn't see it originally is not a big deal. But think about this. Does that graph ever intersect the x-axis? It turns out that it does not. The graph kind of looks like this. Okay? The x-axis is way down here. The graph is way up here. And the graph keeps on going up and up and up in both directions. So this graph never intersects the x-axis, which means that it has no x-intercepts. If it doesn't have any x-intercepts, that means it has no solutions. It means that this equation has no solutions. So let's look at a couple different cases. Let's look at a couple of cases. So I want you to draw 3 different columns here and 2 different rows. Okay? So up here, let's draw a quick graph, quick sketch of a graph. Let's say this is our graph. Draw something like that. Now I'm going to highlight the x-intercepts. Right there and right there. Now if you graph a quadratic function and it intersects the x-axis in 2 different places, that means that the equation has 2 real solutions. Just like this had 2 real solutions. 5 and negative 5 are both real numbers. This had 2 real solutions. This had 2 real solutions. Okay? That means that there are 2 intersection points. Now, unlike in these problems where the 2 solutions are just the opposites of each other, 2 and negative 2, or 4 and negative 4, that won't always be the case. They won't always be the opposites of each other. In the problem set that you're going to be doing after watching this video, they will be, probably, but they won't always be opposites. Okay. Down here, I just want to show you another type of graph. You could also have a graph that is upside down, like this. That's alright. Doesn't matter if the graph is upside down. If it intersects the x-axis twice, it has 2 real solutions. Okay? Now over here, we just encountered a case where the graph never intersects the x-axis. that means that there are no real solutions. And of course you could have this case as well. You could have a graph way down here. It never intersects the x-axis, so no real solutions. Now there's a third case. There's a Goldilocks case right here in the middle. What happens if you have a graph that looks like this? Look at what this graph does. It just barely touches the x-axis. In this case, we say it has one real solution because it intersects the x-axis in one place. And I didn't mean to do that. This should have been right side up, but you could, I'll just put it down here. This is the right side up one. Let's say we have a graph that looks like this. Okay. This, again, is one real solution. So here are the different cases graphically. So I hope this video helped, and I hope that you are ready to start working on the practice problems.